Welcome to Fire University. This is a podcast dedicated to fire ecology and management within the Natural Resource University Podcast Network. My name is Dr. Marcus Lashley. I'm a wildlife biologist, an assistant professor of disturbance ecology at the University of Florida, and a lifelong hunter that's passionate about wildlife conservation and management. In this podcast, I will interview scientists and professionals not only on the latest research in fire ecology, but also about their experiences in hopes that you as the listeners can learn why fire ecology is important and also how you can use it to meet your natural resource management goals. So let's get to the burning questions in Fire University. Hey everybody, welcome back to Fire University. Today, we're going to talk about something that I would say has been a pretty important thing for me personally and you. I'm here with Dr. Carolina Baruzzi.
Oh, hi, Marcus. Nice to, thank you for having me here today.
I know you personally, while you were working on your PhD program, were infected with a tick-borne disease.
Yeah.
And that's what we want to talk about today, not specifically tick-borne diseases necessarily, but there have been a lot of concerns surrounding rising tick populations, spreading of diseases to new areas, and also the influx of new diseases even, they're tick-borne. And me particularly, I've been really concerned about one of those, which stimulated a lot of the work that we're going to talk about today. I don't want the red meat allergy.
Oh, I see what you mean. Yeah, no, I don't want that either. And I'm vegetarian.
Well, you're sort of vegetarian.
Yeah, that's true.
You'll eat wild game meat.
Yes.
Yeah, I mean, like if I cooked a really nice backstrap from a white-tailed deer.
Oh, I would eat that all.
You would want to partake in that, right?
Yes.
And I do too.
Yeah.
But if you get bit by a tick and you get the red meat allergy, you may literally be allergic to eating it.
Yeah.
And that is scary to me because that's not only a disease issue that I have to deal with, or an allergy, I guess, in that case, but it also is a complete change to my food system and the way that I do things, and also a dramatic change to my pastime of hunting, and a really dramatic change to what I do in my everyday life from a business standpoint, where I'm extending knowledge to a bunch of the hunting community generally. So the red meat allergy would be a real game changer for me, and that got me interested in this idea because it's apparently increasing.
Yeah.
Really quickly.
And I also want to point out that with the red meat allergy, you don't just get allergic to meat, right?
Yeah.
So you can
you can. It's like some of the other allergies where there could be many things that stimulate that. I guess I'm going to give the sixth grader version of what I can explain about it. Maybe you have a little better explanation than I do that's more clinically sound or whatever. But essentially, the tick, when it bites you, it's regurgitating fluid into that bite that helps blood flow.
Yeah.
And there's something, particularly in Lone Star ticks, about that saliva that can make your body, reject it, like an allergy. And it's similar to the sugar structurally that you would have in red meats, or a lot of mammalian, some mammals. I don't think it's in all of them, but it's not real clear on why this is all of a sudden a big deal.
Yeah, and it's also not real clear how long it lasts. Like, we don't know so many things about this.
And it's some people apparently don't get it.
Yeah.
It's like an allergy to a bee or a peanut or whatever. There's dramatic differences, and some people grow into it and some people grow out of it, and there's all this weird stuff about it. But I don't want it.
Yeah,
that's what I do know about it. And I know several people who have contracted the red meat allergy, and it's like a severe problem if they eat red meat. Like they need to go to emergency room kind of deal.
Yeah. And sometimes like we had actually a collaborator, you and I, that had the red meat allergy, and I went to a restaurant with her. We were in Mississippi actually together, and we had fried fish. I don't remember. It was typical in Mississippi. I don't remember.
Yeah, fried fish, that's probably
it. And they fried likely the fish in the same oil where some meat have been, I don't know, cooked. And so this person, even if she was eating fish, she felt really sick.
Yeah. Well, and that's scary. And, if we want to add insult, some people even become allergic to any dairy product, or like there's cause for some concern.
Yeah.
It's generally not catastrophic to health like some of the other tick-borne diseases, but that'd be a pretty bad thing for a lot of people that are listening to this probably.
Yeah.
And you may already have it and it's just mild, like maybe you get discomfort when you eat some of those foods or whatever. That it could be all across the spectrum. And I've certainly been bitten by plenty of ticks, and it's alarming to think about the possibility of getting that to me. And that, anyway, we've kind of gotten on a sidebar here.
Yes.
This isn't about the red meat allergy per se, this podcast, but that concern about it, and particularly one of the sites that we were working on in Mississippi while you were working during your PhD, was so infested with ticks. I mean, it was just like it became a thing. It's like, you know what, we've got to figure this out.
Yeah.
What is going on with all the ticks? Because I don't want the red meat allergy and I'm afraid of it. And one of my biggest projects with the most students involved is on a site that's the most infested place I've ever seen in my life.
Yeah, I've never seen as many ticks.
I remember you taping sticky traps around your ankles, trying to keep them from crawling up on you.
Yeah, there were so many that we had to take kind of extreme strategies against that.
I'll take also a minute. This particular property was donated to Mississippi State, and the landowner, who had it in his family for generations, Bob Bowen, he's since passed away. He was one of the most generous people I've ever met.
Yeah.
And I think it showed, the people that showed up to support, and celebrate his life. It's unbelievable. But I sat down with Bob at one point and asked him directly, what are some things that have really changed in this land that you've grown up working on, and you've been on your entire life? He was a big time quail hunter, and that's what he was donating it to maintain that legacy of the property, to continue quail. And that's one of the reasons I was involved, is because to have quail, you need fire. And, I was the person at the time that had an expertise in all that. And anyway, I sat down with him and I said, well, what are some things that changed? And he said, well, when I was a kid, there weren't any deer. And we rode around on horses all the time, quail hunting mainly, but with the agriculture, it was a mixed landscape. They had some agriculture on it. And he said, we rode around on horses, and when things started getting brushy and we wanted to take care of it, we pitched a match out and let it burn.
Yeah.
And he was doing that. And he's like, so we don't have the fire anymore. And now we have all kinds of deer. And he said, when I was a kid, I didn't even know what a tick was.
Yeah, that's incredible, because
now we're on the property, and I've never even seen anywhere like that.
Yeah.
I've been on a lot of properties and a lot of places, and I've gotten ticks on me, and I haven't experienced another place that was as infested as that place.
Yeah.
So those two things were really telling to me. And that's kind of where we're going to go with this conversation. But I think we should talk about a little bit of news first.
Yes, thank you.
Have you been sitting on the edge of your seat like, when are you going to let me tell you?
Say that. No, because you know what? We were talking about game and food and meat. And I'm just kind of like, when is he going to say that?
Well, there's a couple of new developments that I think are pertinent to this audience. And hopefully people out there, you're helping us share this network. I will say I was pretty overwhelmed. Thank you, everybody out there that went and took our surveys. I put out a survey basically explaining that we need to demonstrate that people value this podcast network and all this information. We need to demonstrate that people value it and that we're reaching people and making some good change out there with people managing their properties or whatever. And I was pretty overwhelmed by the response. So to everybody that did that, thank you so much. It was overwhelming, the amount of acres that people, just like for fire, the amount of acreage that people are lighting on fire and using information from this was just, it was unbelievable. But with that, one of the things that we talked about is that will help us justify the efforts and expand it. And there's a couple of new developments that might help us do that. One, I'm really excited to announce to everybody that we have a new faculty member. This will be starting in January in the Wildlife Ecology and Conservation Department here at the University of Florida. Who is that, Carol?
Well, thank you, Marcus, for introducing me. Yeah. So, I'm very excited because in January I'll start, as Marcus has said, here at the University of Florida. I will not be based in Gainesville. I would be at the Research and Education Center in North Florida.
Which is over in the Panhandle.
Yes, it's close to in Quincy, close to Tallahassee.
Yeah.
And my lab will be based on game species, ecology and management.
Yeah. So you've done a lot of work with me and a lot of work with others on game species all over the world, which is pretty cool. Or at least ungulates. They're not necessarily game species, I guess, in some of the cases, but a lot of different ungulate deer species and stuff around the world. A lot of stuff with wild pigs and white-tailed deer, and also a lot of fire ecology. Yeah. You were in a lab as a postdoc for I guess a couple of years. Yeah. Working on a lot of fire stuff, and definitely excited to have you. And this is one of the efforts that that it was one of the efforts that led to hiring me, I guess, at this institution, and now you, and hopefully we'll continue to expand that, where we're trying to bring a focus on game management because of the constituency. There are a lot of people that own land because of that, and we want to establish a presence and get knowledge to those people. So excited to have you.
Yeah, thank you.
But that's also going to affect the podcast network.
Yes, exactly.
So you're thinking about adding a topic area, right?
Yes. So since I'm going to be starting this position, I'm going to be focusing on game species. I really wanted to develop something that I felt like my own. And while I was thinking about it, I thought, okay, how can I also bring, for example, my personality and my culture into my work and what I'm doing? And I'm Italian.
Wait, I thought you were from Southern Louisiana.
Oh, well, I know. I can pretend very well. But no, so since I'm Italian, and as you know, we are very affectionate. We really love our food. And we love cooking.
Food affectionate.
Yes.
Is that your Instagram handle? That should be food affectionate.
Maybe. I feel that would be really accurate.
Yeah.
That's
funny.
So and since obviously many people that hunt because they want to eat their meat, I thought, well, why not starting a podcast where we talk about the ecology of a species, but also we talk about, for example, how we prepare the meat and how we cook certain types of meats.
Yeah. When you've told me a little bit about this, and I love the vision.
Yeah.
Because I've eaten stuff that you've cooked, and I love that, and I love the different cultures and stuff that you can bring to it, and you've worked with people all over the world that are cooking, and I have some recipes that are like my go-to for whitetail or wild turkey or whatever. But there are people that are cooking things similar to that in different places, like where you can pick a place on the map, wherever on the globe you want to go. And I love, eating food from that culture.
Yeah.
And I don't know how to do it.
Yeah.
But I would cook backstraps, in an Italian version of that dish. And I don't even know what that is.
Yeah.
So I think that's pretty exciting that, you could bring that kind of information. And I really am excited to hear about it because, I just don't get that perspective. But we do get a fair amount of feedback not from people on the Fire University podcast, but certainly in the network. And I get plenty of questions like, what's your favorite, recipe for whatever game species? So that's pretty exciting.
Yeah. Thank you. Yeah, I want to highlight the fact that I really like the idea of bringing researchers and recipes from all around the world, because I lived in several countries and there are so many interesting, different and good recipes and types of cuisines that I think it would be very exciting. And obviously there are going to be recipes and research from the United States. I'm sure that.
That's one thing that I have more experience with, going to different places and having people prepare venison or something for me, just even in the same state, not even necessarily around the United States, but I'm always impressed with, I'll get a new recipe or somebody to cook for me and be like, wow.
Yeah.
I'm going to start doing it that way, so I can't even imagine how that would expand if you start bringing in different, cultures and cuisines from around the world. That's pretty exciting.
Yeah. Well, thank you.
Yeah. So I know you've been working on, trying to build that. Another thing for folks out there, we love to get feedback. And if you're excited about that, help us share it, of course. But also give us feedback. Like, what do you want to know about?
Yeah, I would really appreciate that. So if you want any particular recipe or game species that you don't know how to cook and you want to know how to manage better.
Or like maybe you've been eating, well, I'm just going to go ahead and say wild turkey.
Okay.
And you're getting tired of it. That's an impossibility. But we're just going to be, we're going to have a hypothetical here. Let's say you've been eating turkey and you're so successful that you're just tired of eating turkey the same old way and you want to hear how they would do it somewhere else, or a particular type of cuisine that you really like, all that kind of feedback. That's what really stimulates our ideas for these podcasts. And I think that could go a long way in yours when you launch it. I guess at the beginning of next year. So very exciting stuff.
Yeah. Well, thank you, Marcus.
Yeah. So, man, we've probably been talking for 20 minutes or more, and we haven't even gotten to the topic at hand. So, well, we're excited that you're going to be joining us on faculty, and excited about that podcast. I think it's got the makings of something really awesome.
Thank you.
That I think will impact me for sure, because I'll be looking for those recipes that you share online or whatever when you talk to these people about it. But let's talk about ticks, especially given that a lot of the species the game meats that you might cover could be affected by ticks if they gave us the red meat allergy, at least. So I know we've bounced around a lot, but I think that we already kind of covered this idea, at least with the anecdote from Mr. Bob Bowen, that there are kind of two things that people have been pointing at. And I'm talking about scientists and we hear landowners and stuff talk about it too. But scientists, when we're arguing over why are we seeing these changes in tick populations and tick-borne diseases, there are a couple of things that rise to the surface really commonly.
Yes, so these things are, as we mentioned, fire and deer, right?
Yeah.
For example, Bob was saying in his property when he was younger, like he didn't see many deer.
Yeah.
But they lit fires pretty much whenever they thought it was fit.
Well, I think that's something that people fail to appreciate pretty often is that kind of situation where we have multiple factors that are perfectly reasonable causes
Yeah.
that are correlated.
Yeah.
So in other words, they both changed at the same time in ways that might affect something the same way, and we're not sure what.
Yeah,
is
what
actually doing
does
it.
what? Yeah.
So, when at the turn of the century, in the 1900s on up through mid 1900s, we were actively suppressing fire in the eastern United States in particular, and we also, at around 1900, deer were almost extinct.
Yeah.
Which is pretty incredible to think about. But we had a series of legislative acts and also the establishment of game bag limits and things that were associated with some of those, along with also some restoration efforts where we moved deer around and try to reestablish populations. But we basically got it turned around, and that was super successful. So over those same decades where we continued to suppress fire and have the system move more and more to a less flammable system. If you guys haven't listened, we had a episode, probably like the fifth or sixth one, I don't remember what number it is, where we talked about mesification. And that's that process where you interrupt fire and then you start having these plant species colonize that are less pyrophytic, or in other words, they're mesophytic, they're water-loving species. And as those colonize, it makes it less and less flammable in this runaway process.
Yeah.
So both of those two things, this rapidly increasing deer populations, we're also, while we have these systems that are changing into a more mesic, water-loving plant community. So closed canopy, hardwoods in the uplands, and a lot of species like red maple and sweet gum and hickories and stuff like that are less, they don't like fire, and they change the system to make it moister where it doesn't burn as well.
Yeah.
So.
Yeah, because the leaf litter, it becomes like more humid. The more you have like leaf litter from these pieces, it becomes more and more humid.
Yeah. Which
reduce fire. But can we give some spoilers here?
Well, I guess so. We don't want our food to spoil.
Okay. It reduces fire, but also it creates like an environment in the leaf litter that is particularly humid. So it can help certain arthropods, for example.
Yeah. What's an arthropod?
Well,
well, I think we got
ticks. Okay.
Ticks included, right?
Yes.
So I was just kidding. I liked the expression on your face when I asked you that. Like, oh my God, how am I going to explain this?
Yes. It's okay.
So, okay. Well, I think we should kind of specifically walk through. We'll talk about deer first, and then we could talk about fire. How could increasing deer populations affect tick populations?
Well, it's a sort of like, since ticks feed on deer and other wildlife, not only on deer, but basically if you increase the number of hosts, then the ticks are going to be more likely to find a host to get attached and to feed on. Okay. So for that reason, many researchers or people in general believe that if you increase the number of hosts, you also increase the number of parasites.
Okay, so basically, if there are more deer, because ticks spend part of their life cycle on deer, I guess they're breeding or overwintering or something. Maybe something different actually for different species even. Yeah, but a lot of them use deer as one of those hosts. Some ticks might be specialized and other ones can use lots of different kinds of hosts. Yeah. Okay. So the rationale is if we have more deer, there's more hosts to ride around on, which eventually makes more ticks.
Yes, exactly.
Okay.
It's like, think about it that way. If you have, forest, right? When you have like a lot of forage for deer, you could think that that forest could sustain a population, more deer than maybe a forest that have, I don't know, some sparse vegetation here and there, and that makes sense.
But I guess if we're gonna, let's talk about some of the weaknesses with that rationale. So that's a perfectly reasonable expectation if deer are the only host.
Yes, exactly.
So if we have a bunch of ticks that have to have deer as part of their life cycle, then it makes sense having more deer could mean more ticks. But the contrasting statement there as well, if deer are one of many hosts, which is the case for a whole bunch of tick species at least, how many deer there are might be completely irrelevant if they could just use a different host. And as long as there's plenty of hosts around, it doesn't matter if deer are there or not. Because they have lots of suitable options. And as long as those populations are all present, then it's not necessarily going to be negative, even if there are no deer. So, but to be clear, from the literature, and I know we're working on a big manuscript on this idea that we're discussing today right now, so you've really dug into the literature on this, but that's pretty much from what I could tell, and you can tell me better if I'm wrong or whatever. From what I can tell, it seems to be the prevailing line of thought. In the literature, like, why are we seeing more ticks while everybody is pointing deer? Is because we have more deer.
Especially because I think there have been a couple of studies that measure like tick abundance in contexts that are kind of controlled, like they don't have a full real control, but they treat these things as a control. For example, there are some studies that measure tick abundance in forests and in areas that are close to like buildings or where people areas where people live, basically.
So they're using a control like somebody's yard to compare to an adjacent forest.
Sort of, like it's not exactly somebody's yard, but it's like a completely different environment.
It's kind of giving you an idea that they're trying to use a place that doesn't have any deer to compare it to a place that has a whole bunch, and there's more different between them than just a lack of deer.
Exactly. Or for example, there are some studies that are like, I don't want to sound as if we are like too critic, they are really good studies.
There's a lot of great literature, but I think it's a common problem, and people out there probably don't get into the minutia as much as we do. But we have and it's really difficult, especially when you're trying to do it in broad scales, to establish causation. And we have a bunch of these studies where they're really fantastic, but they're correlative. And in other words, we know when we have more deer, we have more ticks, but that doesn't necessarily mean that more deer means more ticks. Like it's not necessarily that more deer actually causes more ticks. They just happen to be commonly grouped together.
Or, I mean, they may cause more ticks, but in a specific context. For example, there are studies that come from Ireland, like there are a bunch from like an island in Maine. I know we spoke about that multiple times, where they remove deer and like tick
so they're literally on an island that's surrounded by the ocean.
So like they remove deer from the island, and they saw that in the successive deer tick sample, they sampled deer throughout the years after they removed the deer, and they saw that they had much less ticks, right?
So basically that looks like, that's a smoking gun. You get rid of all the deer on the island and you got rid of ticks. Or not necessarily got rid of them, but you substantially decrease the abundance of ticks.
So
well, that seems pretty definitive to me.
But it's not actually, because if you look at the wildlife that was available on that island, there were not that many other species there. So like
so basically we're in a situation where deer were the only option. There weren't other wildlife that were hosts.
Yeah, they were one of the few options, I would say. So like,
if we tried, I'm sorry, I'm cutting you off,
no,
but
okay.
You've got my mind racing about it. If we took that same thing to the mainland where the vast majority of people are dealing with this issue, people think, oh, we can decrease the deer abundance and we're going to decrease tick abundance. But you're saying in this context that may not necessarily be one-to-one because we have a diversity of host options.
Exactly, that we didn't have in that particular context.
Yeah, and there's probably some other studies that speak well to this, but if we go to other studies like that I'm familiar with, you have this other issue where if you remove deer, well, you have deer around it and they just move in.
They can always move in.
Whereas on an island, they got to swim to get there. So you're pretty good at getting rid of all the deer, and then there aren't any more deer. But neither is there all these other alternative hosts.
Exactly.
Okay. So with that being said, I think there's pretty strong evidence that deer could play a role in this.
Yes. But it's not as definitive.
Right. We're trying to say it's causative, and that's really commonly what is said and is what is heard. But there are lots of issues with those correlated relationships that we see that could explain, we could have alternative explanations.
Yeah, exactly.
And that's why you need a really good manipulative experiment to try to establish that causation. So we did that. Spoiler.
This is why we're here.
We did that. So that's one of the things we're going to talk about. But before we get there, let's talk about the fire aspect. I think most people probably think about this issue the same way that I initially was thinking about it, whereas it's pretty obvious if you got a bunch of ticks all over the vegetation and in the leaf litter and you set it on fire, that ain't going to be good for ticks.
Yeah, exactly.
So that's a direct effect.
Yeah, but as we mentioned earlier, there are also indirect effects of fire because fire generates an environment that it's less humid, is more dry because it removes leaf litter. So when you have an environment that is more dry, well, then arthropods like ticks are more likely, for example, to desiccate and to suffer from heat stress.
So we could directly kill ticks with fire.
Yes.
Or we could remove the leaf litter and make it drier, essentially. Another thing that happens is there are actually some species of predators of ticks. There's some evidence that ticks in that environment are more vulnerable to predators of ticks.
And in general, some, like for example, some ground nesting birds, they are attracted by fire, so maybe they are not necessarily going to like close to recently burned areas to eat ticks. But if there is a tick around and they are just going there to forage, well, they may eat them as well. So if you increase the presence.
I wonder if turkey poults are they going to gobble up that tick? I don't know. I need to know. I want to know. I think they would. Yeah. Especially if they're about 6 days old. They're going to eat that tick.
Okay.
That's my instinct. I don't know. I don't have any evidence to. That's just a completely conjecture. I don't know, but that's my guess. So okay, but then when we were talking about the changes that kind of coincided at the beginning of the 1900s. Where we had this long-term change as well. Yeah. Where if you don't burn, plants succeed into a moister community. And that's kind of what you were talking about with it. Burning makes a drier environment. Well, not burning makes a moister one. And you have these contributions of leaf litter that have they're structurally different, but they also hold water better by design.
Yeah.
The plants are literally engineering a moister system, which is probably beneficial to ticks that have to worry about desiccating when they're not on an animal but instead in the environment, often waiting on something to jump on like me.
Yeah, that's true. And also, I don't know how much this plays a role, but if you think about it, if you live in a leaf litter that is all like
Compacted,
packed, all compacted and moist,
Mm-hmm.
you may also be less likely to be eaten by something else.
Yeah,
Right?
well, I think that's probable.
Yeah.
You could definitely decrease predation risk
Yeah.
of the tick, which is weird to think about.
Yeah.
Most people are probably not thinking, of a parasite being vulnerable to predators, but there are some things out there, some other insects or arthropods or
or
whatever.
even mammals and birds that eat them.
But mammals and birds too.
Mm-hmm.
So they could be less vulnerable to those, and they also could be less vulnerable to changes in weather or whatever. So there's a lot of stuff going on here.
Yeah.
But again, we don't have, surprisingly, we don't have that many studies looking at fire. That definitely has been a less popular avenue of research to try to understand this change that we've been seeing.
Yeah.
But there are a few. So what are those studies? And by the way, we'll provide links to these studies.
Oh, okay. Yeah.
In the show notes. So if you want to go look at these for yourself, we'll provide that.
So there are several studies on ticks and fire that have contrasting results. This is likely because it's very hard to study fire because you need to take into account like the fire history and a characteristic of the fire per se. Like, for example, how big is the fire, or in which season the fire was lit, and all these things that are really hard sometimes to control.
Yeah.
And
that makes sense.
Yeah, and especially it's very hard to be able to practically find places that have the same fire history and burn them more or less, at the same time.
Yeah, and then replicate that at a level that you can.
Exactly.
And then tick populations naturally vary through the year and from year to year.
Yeah.
There's lots of fun stuff for us to try to figure out. That's one of my favorite things about being a scientist, to be honest with you.
Oh, really? It's kind of a headache, though. No.
Well, I like it. It's sort of like a puzzle or something. It's like, wait, we're trying to isolate this thing to understand this thing when there's like a million pieces of the puzzle that you can't account for.
Yeah, that's true.
It's like having a puzzle. Let's imagine we have, I don't know how many, let's say 10,000 piece puzzle. I don't even know if they make one of those, but we'll just say we got 10,000 piece puzzle, and I give you 4 of the pieces. And you have to figure out how they orient relative to one another without any of the rest of them.
Yeah.
That's tough.
Yeah, I think it's a very good description of ecology, though, because
we're often trying to get a few pieces when we have literally thousands and thousands of other ones that are factoring in.
Yeah, and sometimes we don't even know. I feel that's the thing. Like sometimes you don't even know how many pieces there are out there.
But if we take that same analogy and you took that 10,000 piece puzzle, and you're interested in these 4 and how they fit into that puzzle, and you we'll say, quote, control the other ones by going ahead and orienting them all to one another. So in other words, you put the whole puzzle together except for the 4 pieces, then you can really understand how those 4 pieces fit into the puzzle.
Yeah, absolutely.
Right? That framework is now there. And that's what we're trying to do with experiments is essentially we're trying to get all of those things controlled for so that you can isolate the thing of interest.
Yeah, absolutely.
Which is really good way to think about it, I think.
Yeah, no, it's a very good analogy.
It's really fun.
Yeah. But so that's one of the issues that we have with understanding aspects of fire ecology is that it's so broad and there are so many. It's not just fire. There are fire characteristics that are affecting our results, and that's the same in our tick research. So there are studies that, for example, burned a place that haven't been burned for a very long time. And then they look at tick abundance. Or there are studies that look at fire that had very different sizes and look at tick abundance. So it's very hard to compare them. I think we have recently spoken about them.
But let's kind of generalize some of those results. So what you're saying is across studies, sometimes fire has a negative effect on ticks. Sometimes it doesn't have an effect.
Yes, and there are a few that also show a positive effect.
Oh my gosh.
Yes.
Wait, so we burn and we get more ticks.
So that's what they saw in some studies.
Yeah.
So that's why I'm saying it's really tricky. Like there is
So-
really contrasting evidence.
So people out there, it's like, well, burning couldn't hurt. Well, there's some evidence that maybe it does.
Yeah. So that's why it's hard. I think
I found that hard to believe.
Yeah, no, I have to say there are a couple of studies, especially coming from Georgia and North Florida,
Yeah.
that I know you know too, that actually show that if you have like a consistent fire regime, so if you don't just look, for example, at one fire and then all that is done, let me measure tick abundance.
Yeah.
But if
I think that study is pretty telling for several reasons. I think it's one of the best studies.
Yes,
in
it's a
terms
really
of
good study,
looking at how ticks respond to fire, but it paints a picture in a couple of ways. And I know you were getting to this, but one is it isn't just one and done.
Yes,
where you just go out and burn. They found, they were kind of portraying it as you need a consistent regime of fire where you're repeatedly across the landscape coming back and burning over and over again.
Yes, exactly.
Not, maybe that's on a 3-year interval or 2-year or whatever.
Yeah, but you need to be consistent.
Yeah, we consistently have fire touching the landscape and across the landscape.
Yeah, exactly. Okay. That's really important.
Yeah.
And I mean, I feel that could be kind of the same with, sorry to jump back to the deer, but if we have like a more healthy, and balanced wildlife community, then, you may have, I don't know how I think I may say something that is too out of the way.
Well, that's fine. I get what you're saying. Like if you're, let's say that you own 1,000 acres and you got a tick problem.
Yeah.
Well, one option potentially is to decrease deer abundance.
Yes.
And you may or may not see an effect of that. We're going to talk about that in a few minutes, a little more definitively, but that would be a recommendation potentially that people would make, professionals would make to someone, is to decrease deer population. And that probably isn't going to work in that context because the surrounding landowners still have a lot of deer.
Yeah.
That's one reason. So that's kind of what you're saying. Another thing is decreasing deer in that context, if there's a diversity of wildlife, may not actually result in less ticks because they have something else to ride on.
Yes, exactly.
As a host.
Exactly.
I do want to talk about one thing about that before people think wildlife diversity is bad.
Yeah, no, it's
there's another thing in the tick disease world that I find extremely fascinating, and it's very well supported as far as I can tell. Much better actually than the deer versus fire conundrum that we're getting into, but it's the dilution hypothesis.
Yeah.
And essentially what that means is there are these ticks that are generalist and can ride a lot of different kinds of hosts, but some hosts are really good vectors. I don't know, that's probably not the right word, but they reservoirs, maybe that's the better, I think that's the more sound word. So they can house a disease, and the tick can get, contract the disease and carry it from that host.
Yeah.
Whereas the same disease might really be poorly, other wildlife species were a poor reservoir of it.
Yeah.
So when you have wildlife diversity and you have ticks in a population that are using many different kinds of hosts, then essentially what we're talking about with dilution is, because there's so many host opportunities, it interrupts the disease because ticks end up consistently running into a dead end for that disease. I don't know if I've explained this well, but
no, I think I was actually thinking, thank you, Marcus, for explaining that, because
you didn't want to do that.
That's what
well, it's kind of a complex idea, but essentially, if you have 10 potential hosts for a tick, and that 2 of those 10 can carry Lyme's disease really well, but 8 of the 10 can't. You will consistently see many fewer ticks with Lyme's disease because they often feed on a dead end host for Lyme's disease.
Yeah. And you know what actually this is? Can we take a second for like do a shout out to our herbs, like to our reptile community? Because there are studies even from our department here at UF.
Yeah.
That show that reptile can
like lizards, anoles, and
and snakes can have like tick attach and feed on them, but usually they are, since they're reptile, like they're not mammals.
They're usually a dead end for the diseases.
Yeah. I don't know like to which extent we could probably like put
we're not experts,
but
we're not experts on all that stuff, but that is a thing.
Yeah.
So that's one reason that even if you just own land to deer hunt, or you just own land because you want to do one thing on it, there's a lot of value intrinsically to diversity.
Yeah, exactly.
That some of it we don't even understand well, and even as ecologists, we don't understand this particular thing very well because it's so complex. But having a whole bunch of lizards might be doing you a really solid service. Because you're getting bit by ticks, but they don't have any, they're not carrying any disease because you got lizards.
Yeah.
Like what? What do you mean? Like, you're out there, I get it all the time. I get tons and tons of pictures of snakes.
Yeah.
And a lot of times those snakes are no longer living because people are afraid of snakes. And that's unfortunate because stuff like this is happening where they actually are an important part of this cycle. And, they are a valuable part of the way the system is functioning. And it's too complex.
Yeah.
We don't understand.
Snakes may actually eat some of the mammals that.
Well, that's what I'm saying. Like, it's even more complex than them just being a dead end host. They also love to eat things that are the best hosts of the diseases. Yeah. It's like, okay, we're kind of geeking out over this.
Sorry,
but diversity is valuable.
Yes.
It's not just about tick abundance, it's also about how they're infected and all that sort of stuff. So I don't want ticks on me either way.
Yeah.
But diversity might be critical from that aspect. So anyway, we kind of bounced around. Let's get into the study that we both did.
Okay.
We had a lot of people involved in this. You heard from Rainer Nichols for one, who was a graduate student that was working on a lot of the fire stuff. Mariah Bogus is the one that led a lot of the tick collection. I've heard from him a few times. We've all been working together on a lot of these issues and bringing you this data as it comes available. Mm-hmm. We haven't published the tick work yet. We're working on it. So we can't provide that right away, but hopefully that'll be soon. Mm-hmm. And we're pretty well to a point now where we're comfortable talking about it.
Yeah.
And that the analyses are where we think they're going to be finished.
Yeah.
So, all right, let's talk about that experiment. So what did we do?
Well, so we first of all selected 4 different sites. So we had a pretty good replicate, let's say, at the site level.
Yeah. And so we had 4 sites where we're going to do a bunch of stuff at each site.
Yes.
So a lot of people aren't thinking about experimental design. So I'm not repeating it because I didn't understand you or they didn't. I'm just trying to repeat it for people who aren't thinking about experimental design all the time.
Okay, thank you. Well, thank you, Marcus. Okay. Okay. So basically at each site, we had areas that we didn't burn. Yeah. Some areas we burned during the spring and some areas we burned during the summer. Okay.
So we had a March fire, which is typical, everybody does.
Mm-hmm. We were in Mississippi doing this.
This was, and it was across several sites in Mississippi.
Yeah.
So from the center of the state all the way up into the northern part of the state.
Yeah.
There also, for those of you interested out there, we had pine plantation all the way to upland hardwood.
Yeah.
So a lot of different kinds of systems.
Mm-hmm.
All right. 4 sites. We also had a whole bunch of replications.
Yeah,
so we had a control that we didn't burn it.
Mm-hmm.
We also had each of those other fire treatments together in the same place multiple times on each of those sites. I think it totaled for 14 replicates.
Yeah, I think so.
Across 4 sites.
Yeah.
Very good study in terms of replication and having it across a wide range of different vegetation types and So pretty good on all those things.
Yeah.
Also randomized block design where, we have all the treatments represented at each one of the sites.
Yeah. So this was for the fire aspect of
Yeah.
the experiment. For the deer aspect of our experiment, we selected just one site. This is for practical reasons because it's very hard to,
Yeah. We also couldn't kill all the deer.
Yeah, not definitely not. So we used a fence, an electric fence, to kind of reduce deer abundance. So we were not really removing deer.
Yeah, but it kind of simulates what's practical for most people.
Yes, exactly.
I mean, a lot of people don't want to get rid of all their deer.
Yeah.
They might be able to deal with a few less deer, and maybe it's even desirable for them to have less deer for
I took care of that fence with other students in Mississippi, and I say I would so much rather deal with more deer than with that fence ever again. But
so we basically put up fence, and it didn't keep deer out of it completely, but it did substantially reduce deer use inside of it.
The fence.
So it's simulating what would happen if you shot more deer and had fewer deer.
Yeah, exactly.
But that it's not practical in almost any scenario to get rid of all the deer.
Yeah, no, it's
on the island that we talked about, that experiment, that's one of the few places where it's actually a practical. Actually, then it was even really difficult what they went through to try to do that.
Yeah.
But that's a scenario where you can relatively easily, compared to almost any other circumstance, you could relatively essentially eliminate deer from the picture.
Yeah. So in that site, the site with the deer fence, we placed deer fences that were basically preventing deer or like reducing deer abundance in half of all our fire treatments. So basically there were some areas that were unburned. And they were both fenced and unfenced.
Yeah. We had high deer abundance, and that site has a really high deer abundance.
Yes, and also has a really high tick abundance. It's the one that we were mentioning at the beginning.
Property that, so really high deer abundance, no fire.
Then there was
that on the landscape. I'm talking about that property, and then we put in these treatments where we have a fire treatment and a control treatment. And then we also have that with high deer abundance and low deer abundance with this fence strategy.
Exactly. Unfortunately, because of what we were talking about earlier, so because of mesification, we could not have a summer burn treatment.
Yeah, because the system, we actually tried many times over again.
Yeah, for 2 years.
You and Mariah had to change your focus of your research because we couldn't get the June fire to carry on the system, like, closed canopy, upland hardwood. June fire is not happening.
So we just in that particular property, in that particular site, we just had an unburned, unburned treatment and spring.
So the March fire versus no fire, with and without high deer abundance.
Yes.
Okay, and then we carried that on for a few years.
Yes, 2 years. I mean, the fire treatments the fire was lit once, and then we sampled tick abundance for 2 years. Like the same year of the fire and the year after.
Which then, in most cases, we would be applying fire again. So we're kind of measuring tick abundance over the entire course of the fire return interval.
Yeah. Okay.
So.
Well, the results were really striking. Can we talk about the results, or do you want to say something?
No,
before?
I think we should lead them on for another hour before. Let's talk about the results. I know you're sitting on the edge of your seat. You've fallen to the floor a few times. I know you're excited about this.
Yeah. No, because they were so striking to me.
Yeah.
I didn't, honestly, one of the things I love the most about science is not the puzzle part that you can keep.
It's the excitement of discovery.
And discovery.
Especially when it's surprising.
Exactly. So finding something that you did not expect. It's one of the best things in science.
So let's recap. For one thing, those of you listening out there, I want you to take a second to think through this. Well, based on all that, what do you think happened?
Oh, yeah. I can tell you
we've reduced deer
happen.
abundance substantially. We also have 2 times of fire that happened and no fire. We actually didn't talk about one of the experiments that I think is particularly important, but we'll get into that. We have another more definitive explanation of why we saw what we had to, where we were trying to isolate the mechanism. So in other words, establish that causation. That's why we have so many experiments. We're trying to piece together, we have several pieces before we approximate causation, and that's what we're trying to do here. But yeah, let's talk about deer first. What happened with deer? So you have the substantial reduction of deer.
So for years. Okay, first, can I say what I was expecting?
Yeah, please.
Thank you. Okay. I was expecting fire in general, didn't matter the season, to decrease ticks. Because as we said, we have already explained why, right?
We thought fire will mean less ticks.
Yes. Then I was expecting areas with less deer to have less ticks. And then I was expecting areas that particularly had less deer and fire to have like way less tick than anything else.
So basically you were thinking fire is bad for ticks, deer is bad for ticks.
Deer is good for ticks.
No, I meant less deer.
Okay,
the deer treatment. Sorry. No, you're right to point me out. Make sure we're specific. Adding fire means bad for ticks. Reducing deer means bad for ticks. Adding fire and reducing deer means really bad for ticks.
Yes, exactly. That's exactly what I was expecting, which I think it's like a reasonable expectation, right?
Oh yeah, that is similar a line of thought to what I thought.
Okay.
And based on the literature, one of the things that was novel about this, one, we have a lot of replicates, and that's really unusual. And to have, this kind of experimental design is not super common with this particular topic area. But when you go and look at the literature on fire, and I talk about this all the time, we don't, even when we have growing season fire, it's super common for us to study these things with a March or April timeframe, with give or take a month sometimes, and sometimes we're doing dormant versus growing, and you might have a February versus a May or something. But most of the tech studies, as far as I remember, almost all of them had that March, give or take a couple month time frame when all the fire is being done. So I really haven't even looked at the summer burning that much. So that was one thing that I thought was really interesting about this. And we had a whole bunch of experiments comparing the timing. And this was, we added to it to try to understand more about how those treatments were affecting the system. But yeah, so I was with you. I instinctually thought the timing was probably I thought the adding the summer fire was going to magnify that relationship that you just said. So in other words, burning in March with fewer deer would be really bad for ticks compared to burning in March or not, reducing deer.
Yeah.
I thought both of those would have an effect, but it'd be magnified by the March, but then we would magnify it again. So we'd have even bigger negative effect on them if it was June.
Yeah.
And the reason I thought that was because a lot of the ticks that are riding on host are riding on them over winter into that early growing season, and then they're kind of dropping off in the environment. And then we would not only have the system changes with the leaf litter and all those things we talked about, but we'd also add that direct effect of they're all sitting in the environment vulnerable in the leaf litter or in the vegetation and during the summer fire. And that's what I thought was going to happen.
Yeah. Well, you are very close, actually.
Well,
yeah.
They do pay me to
to do, yeah.
I'm just kidding. It turns out they pay you to do that too.
Yes. Very happy about that. Okay.
Yeah.
No, so we saw in the first year we burned them.
Well, let's talk about deer. What happened with deer? Because we started with deer.
First with deer. Okay. Well, with deer, it was actually pretty unexpected because they basically did not make a difference.
Okay. So we got didn't get rid of the deer completely, but we reduced deer abundance substantially.
Yes.
And they had no effect on ticks.
Absolutely none. So in the areas where we had the abundance reduced, we keep finding exactly the same amount of ticks in our
If you walk
traps.
in there, do you get ticks on you?
Oh my God. Like, I cannot tell you, like, there is no, like, if you don't see it, you cannot believe it, how many.
Yeah, it really is.
Yeah.
It's amazing. So it's a great place to do that experiment.
Yeah,
because
exactly.
if anywhere we should see an effect of reducing deer, it would have been there.
Yeah, it would have been there.
Because we had a lot of deer and a lot more ticks. And then it was like, well, if you get rid of some of the deer, we ought to see some reduction in ticks, because at that level of ticks, you just can't sustain it, right?
Yeah.
That's what.
Yeah.
So that was as good a place to do that. And after a couple of years.
No, absolutely nothing, like zero.
Well, that doesn't seem very exciting.
Yeah, no. I mean, it doesn't support very much the idea that...
It is kind of exciting on a different front, because we've been pointing our fingers at how negative deer are.
Yeah.
And for a lot of reasons, but this is another one. And our study doesn't support that at all.
No, absolutely not. Yeah. Yeah. So
it's that pesky wildlife diversity.
Yeah.
Well, they just ride on something else.
Yeah. Oh, I don't know if we said that, but yeah, our fence
that basically excludes deer, but nothing else.
Yes, exactly. Because it's one of those electric fences that otherwise I can pass under it.
Yeah.
And we had camera traps inside, so we could monitor deer use.
Another thing I'll just add in there, because it's always a question. We didn't have any pigs.
Oh, okay.
So there's another similar sized animal that were not present at in any of these sites. So people always ask about that. We didn't have any on these sites.
Okay.
Go ahead.
Okay, no, I was just saying, that we had camera traps, so we knew.
Yeah, we basically monitored what are the tick hosts inside the fence versus outside. There's no differences except for deer.
Yeah, exactly.
So, okay.
Instead for fire,
which we had a lot more replicates across the landscape.
Yeah, that's true. Because for fire, we had 4 sites where we were doing that. 14
total replicates.
Yeah. We actually had slightly different results from year 1. So the year where we lit the fire, and year 2, the year after the experiment and the fire.
And then in year 3, we would have lit it again, because we were on 3-year interval.
Okay. So basically the first year that we burned, there was no difference. So we found the same amount of ticks in our tick trap in the burned areas and in the spring fire areas. So
let me I like to re-say what.
Oh, thank you. Yes, please.
I mean, with everybody. So what you're saying is, we have a bunch of control areas, which means we didn't burn it.
Yeah.
We had a baseline number of ticks. And then we went and sampled in those places, and then sampled in the summer after we've burned in March.
Yeah.
Sampled the adjacent block that's been burned that year, and compared that to the control that's directly beside it where we didn't do anything.
Yeah.
And there was no effect on ticks.
No, none. Again,
we had exactly the same number of ticks in both of those.
Well, what's funny is that we actually had more in the spring.
Oh my gosh.
But wait, when we did the analysis, it was not really statistically significant. So we cannot say it was more.
So we had some evidence that there tended to be they weren't different based on the analysis, but if you just looked at the raw number of ticks.
Yes, it was more.
We actually captured more in the March than we did in the control. So it certainly didn't reduce the number of ticks.
Yes, definitely not.
If we had 100 more replicates, we might have even seen that it increased it. But there's too much variation to know.
Yeah, exactly.
But what we can definitively say is burning in March didn't mean less ticks.
Yeah, the first year.
Okay.
So burning in June instead, dramatically reduced the amount of ticks that we found in our traps in year 1. Okay. So one can say.
You said an interesting word there. You said dramatic.
Yes. Dramatic is almost none. So dramatic means that we had traps, for example, in the burned areas with between 20 and 50 ticks each.
Yeah,
okay.
so maybe we should tell people kind of what we're doing here.
Okay,
so you've got this little square of cardboard.
Mm-hmm.
You get some double stick tape. You folks can do it out there.
Yeah.
In fact, it'd be kind of cool if we had a whole bunch of people do it and then
and let us know what you found. Yeah, absolutely.
So we can see how many ticks you got. But if you wanted to do this for fun, I mean, it'd be good to do with a kid or something that, is kind of fun.
Yeah.
But you essentially have a little square of cardboard.
Mm-hmm.
You put double stick tape around the edge of it. You set it on the ground, and then you put a little cube of dry ice in the middle, because ticks try to find host based on CO2.
And dry ice.
Dry ice as it dissolves or whatever, it releases CO2. So the ticks try to get to the CO2 source, and they get stuck on this tape.
Mm-hmm. Exactly.
And then we can count the ticks.
Yeah. So what we found...
one thing we also didn't mention, but we need to talk about this. We sent all these ticks off to a lab and had them screen it to see what diseases pathogens they were carrying that they could give us.
Yeah.
Which to me was a bad idea, because now I know what all they have, and it's not good.
Yeah, definitely not good. Yeah.
And you got Rocky Mountain spotted fever.
From them, which was the most relevant prevalent disease in the ticks that we found. So as soon as I saw it, I was just kind of like,
oh my gosh,
that was it. Yeah, but no, it was almost 50%, something like 48.5% of the ticks we sent for disease, to test for diseases had them. So almost half.
50%. We'll just say 50%.
Yeah.
Half of the ticks that we sent have sampled and screened for a disease that we can get from them.
Yes. And I can tell you it's really bad. It's not fun.
And this wasn't just on the one site. This was across all those sites.
Yes.
So check for ticks, folks.
Yeah.
Like that. The good one silver lining to that is a lot of those things, they have to be on you for an extended amount of time before you contract it.
Yeah, and I think it depends. The tricky thing though is that I think it depends on the disease. So I actually looked it up. Rocky Mountain spotted fever, it's a minimum amount of time, so it's 3 or 5 hours. I got it. I think it was on me like around 4 hours, no more than 5. And I still got it.
I'm never going outside again.
No, don't say that. You should burn. That's what it says.
Set it on fire.
Yeah.
You remember that time I said that it wasn't fun to burn during the summer? I'm going to retract that statement.
Yes.
You know what is fun? Being able to go outside and not get ticks on you.
Yeah.
So, okay. So let's recap this real quick. So now people have an idea of what we're doing. We have a whole bunch of these little things that we're sampling, and we leave them out for a few hours. It's sort of like, I'm going to go back to an analogy that some of these people will relate to because it resonates with me. If you were a turkey hunter and you sat on the ground for a few hours, which is commonplace, that little trap is essentially
you.
Yeah, it's monitoring. We did it for 3 or 4 hours. I don't recall what. But that basically is signifying how many ticks would have crawled onto you if you didn't move.
Yeah. So that's a really good analogy. And I can tell you, like, from what we saw in our first year, if you are in an unburned area, probably you could have had, what was the mean? The mean was around 10, I think.
Okay. So if you sat on the ground for a few hours, which I do a lot,
you are likely to get around 10 ticks on you.
10 ticks crawl up on you.
Around, yeah.
Without even moving. 10 of them would crawl. They would smell you or something. Yeah. I don't know. We're going to say smell.
Okay.
They detect your CO2 emission. And then they would walk over and jump up, or they probably wouldn't jump. They would walk up and then crawl up onto you.
Yeah.
Oh, I'm getting crawlies right now just thinking about this.
Yeah. And I mean,
10. That's a lot.
That was the mean. So you could have had, like, we had few traps that had none, some that had 15.
Yeah, that's on average across all the sampling and all the sites within the areas that were not burned.
Or the areas, the mean was very similar. So it was around 10 that were burned during the spring.
Well, another thing, I think we had some that had 60
Yes.
Another thing that people might be thinking out there, it's probably all those little seed ticks.
No, we
those little tiny
excluded
ones.
them.
We didn't even count those.
Yeah.
We left those out because they don't carry any of the pathogens, right?
And also because we were afraid that they could have kind of skewed our results
because if you happen to set the trap next to a tick bomb, we'll call it, where you have a hatch of these little bitty tiny ticks.
Yeah. You get hundreds.
You could get hundreds or even thousands.
Yeah.
And I know I've walked into some of those and you literally will have thousands of ticks on you from brushing on one branch. We didn't want that to skew the data.
Yeah.
So we're just talking about like ticks that are old enough that they could feed on you, and they have probably fed before, which means that they can carry a pathogen.
Yeah, exactly.
So that
instead, the mean.
Does that make you crawl at all? Like just. When I get in bed tonight, I'm gonna be crawling thinking about this.
No, I don't know if I'm gonna be crawling, but like.
It's like everything that touches you is a tick.
Really? Like,
how do we burn them all down?
Yeah. But no, instead the mean of the number of ticks found per trap in the places that were burned during the summer was very close to 0.
Yeah, it wasn't 0. We detected a few.
Yes.
But it was almost 0.
Yes.
So if you sat in the recently burned area that was burned in the summer.
Yeah. To give you an example, we have like all traps had less than 10 ticks.
Yeah, all of them.
All of them, yes.
Whereas that was the average number.
Yes, in the other ones.
So all of the traps had less than the average for the other treatments.
Exactly.
Okay, that's a pretty big difference.
It's huge, but I think it's very important that we sample in 2 years, because one could say, hey, maybe that's an effect of the time of sampling, right? Because
it's just because it hasn't been that long since fire.
Exactly. So like if you let more time pass between the fire and the sampling, then you have more ticks coming there, right?
Mm-hmm.
Instead, the year after, we saw a very similar pattern. We saw that there were slightly this time less ticks per trap in where we sampled, like in sites that were burned in the spring.
Yeah.
But the number were still very similar.
So in year 2, so we burned in 1 year, go through that growing season, then look in the next growing season in the middle of the summer, how many ticks from when we burned in March. And there were slightly less ticks in that March burn than the place that we didn't burn.
Yes, exactly.
And again, this was replicated on 14
times. Yeah.
14 times.
Yeah.
So that was consistent that we tended to see a few less ticks.
Yes.
So
not that many.
So it's kind of also speaking to what we've been seeing in the literature, where we have these experiments that sometimes show negative and sometimes positive effects, which we saw both of in ours, but then in the longer term, it tends to be negative.
Yeah.
And that might be one of the one study we were talking about from South Georgia and Florida that's really talking about the importance of the regime. They also showed that having the effect of fire was stronger when you had the units around it were all burned. So it's kind of speaking to both of those things where, having a long-term fire regime with burn units all around the one that you're in is also important.
Yeah.
What they showed, but we're kind of seeing that play out, but we have it in the design where we can kind of isolate that timing seems to be pretty important.
Yeah, absolutely.
So in the longer term, we tend to have fewer ticks in the March burning.
Yes, at least, that's what we saw in our experiment.
Right.
But the June burn was still dramatically lower, like the number of ticks found in the June burn, in the Arab burn.
So even though we're a year, we've gone through a growing season, now we're in the next year after burning, we still have a substantial decrease relative to the control and the March burning. Right?
Yes, exactly.
Okay.
So
way less ticks.
Way less. Like it was incredible. And if you think about like the disease risk, since we know that 50% of these ticks can carry a disease.
Yeah.
Well, if your mean is 10, it means that if 10 ticks crawl on you, 5 maybe
on
carrying
average, 5
a disease.
of them. Yeah.
Yeah. Instead, if your average is 1 or 2, like
if it's 2, then you got 1 tick that you got to worry about.
Yeah,
if
instead of
10,
5. Yeah.
Okay. And that's just over a couple hour period. Like just sitting there for a couple hours.
Yes,
like that'd be the difference. And you have 5 times the risk.
Mm-hmm.
So that's really, really crazy. Well, another thing we were interested in is, there's another potential thing, especially when you're thinking about how all these wildlife are contributing to the disease prevalence in the ticks. And another thing, we know that fire is affecting where animals are going. We thought maybe that the prevalence of disease in the ticks might be influenced by the fire. And that's not what we found, right?
No.
Basically, the same proportion of ticks have a disease, whether it's in no burned area or, whenever it's been burned, or whether or not there's deer even. The same number of ticks still had diseases in terms of the proportion.
Yeah.
But you have way more risk because of the abundance of ticks. You have so many more ticks.
Yeah.
Okay, so right now we've got a really good experiment all the way around. I think a lot of replication. We're manipulating things and trying to isolate them, which is really cool. And like we've just said, removing deer didn't really matter.
Yeah.
But adding fire did, especially in the long term.
Yeah.
And particularly if it's growing season fire. In our case, it was June lit fires. That had a really big time negative effect on tick abundance.
Yes.
And it did not influence what proportion of ticks were infected, but it did did impact the risk of being exposed to one of these pathogens because of the abundance of ticks.
Yeah.
So that's, I think, an important point. We didn't know really what to think, but we wanted to take that extra step to make sure we're covering our bases here, because this is a big time issue.
Yeah.
We're trying to figure out on a landscape scale, what are we going to do? And people have run some of these experiments like these islands, and they're like, well, just get rid of all the deer. Well, that's not really practical in most cases.
Yeah.
So what are we going to do? And that's what we're trying to figure out here. Seems like growing season fire is a really good answer. Question that I then have is why? What is it about fire? What is it about the growing season fire? What is actually causing the changes? We have pretty solid evidence that there is a big time effect of that, but what is actually happening?
Well, that is a good question. We tried to isolate one of the mechanisms that we spoke about earlier, and this is the leaf litter, right? Yeah. We were saying that a very moist leaf litter can promote ticks and tick abundance. So we actually used an experiment that was coming from Heather Alexander lab. I think it's important to mention that. And in that experiment, we had different types. We sampled leaf litter. I actually went out in the field and spent like a couple of weekends getting leaf litter. And
let me just paint a picture real quick for folks. We got a bunch of students, and I did some of this too.
Yeah.
Not as much as you did, but that's why, you were a student. I wasn't at the time. I did plenty of sorting through leaves in my own graduate programs. But essentially, we got a bunch of folks outside in the woods catching leaves when they fall off a tree in nets. Like just nets kind of under the canopy of trees, catching all these leaves and then sorting through them.
Oh, wait, when I did it, I was like literally sitting on the floor and making bags. No, it's true. We were listening on a true crime podcast. I can tell you this.
You should have been listening to Fire Universe. It wasn't.
No, it wasn't there. At the time, but we were sitting, all of us, on the leaf litter. It was winter, so it was also cold.
Yeah.
And we were just sorting. Like we had, each student was collecting a particular type. So I remember I had I was doing oaks.
Oaks.
And I was just, dividing them by species.
So we're literally, regardless of how you get the leaves, some of them we captured before they hit the ground. Some of them we actually picked them up off of the ground. But we literally got a whole bunch of students out there sorting through leaves and putting a single species, like red maple or oak,
bag.
one of the oaks or whatever, filling up bags like garbage sacks,
exactly.
full of leaves of this particular species.
Exactly.
Why did we do that?
Well, we did that because we wanted to sort of like recreate and control for just the leaf litter
the
side
leaf litter
of the
itself.
Experiment. Yes, exactly.
And these are the kinds of things that we really need to do to establish causation. And we often don't do it.
Yeah.
We'll just say that. And I'm including me right in there.
Yeah. Everyone. Like it just.
They're way harder to do, especially when trying to answer questions that are scaled, like this.
Yeah. And I would also add to the fact that it's important to pair them, right? It's important to pair from what you see in the field and what you see when you isolate certain factors. Right. So you need both.
Yeah, that was one of the things we were doing when we're catching leaves. We're trying to figure out, okay, how much of the leaf litter is contributed by a particular species as you continue down the gradient of mesophication.
Exactly.
So as all these tree species invade, like red maple or whatever, how much of the leaf litter that is on the ground is actually being contributed to those? So we've got all of that and we figured it out, and we've kind of established this gradient in this experiment where we collected all the leaves and we kind of simulate, right, in plots, how much of the leaf litter, how much leaf litter should there be there?
Yeah.
So we basically rake out this plot. Then we put the amount of leaf litter that's supposed to be there. And then we put a whole bunch of mesophytic litter based on a mesophyte forest in one plot. And then we have a paired plot right beside it that, we put in the same amount of leaf litter biomass, but it's more pyrophytic or oak in this case, leaf litter. So we're simulating, okay, if we had a forest that is, was historically relevant, it'd be more on that pyrophytic side. And we have real data that has told us how much leaf litter to put there. And then we have the mesophyte forest where we have the appropriate biomass and amount of leaf litter. And we actually did some experiments with burning on those, trying to look at how it affects fire behavior, which we published. Like you mentioned earlier, I was a committee member on that student's program, but at the same time, Mariah went out and put these tick traps in it after they had sat for several months. So we put out this leaf litter, and then we leave it there for a real long time to kind of let ticks do their thing and figure out where they want to hang out or whatever. And then we went back and sampled it to see how many ticks were in the different kinds of leaf litter.
Yeah.
Right. So now we're kind of getting at that. We've isolated one mechanism, which is the system itself, because of the lack of fire, changes in this way with leaf litter. Does that change in leaf litter affect ticks?
Yeah. So in this sort of mesocosm experiment, what we saw was that the basically abundance of mesophytic leaf litter was increasing ticks, which was, I think,
so the moisture leaf litter actually is a plausible explanation.
Yes, and it was particularly when leaf litter was unburned.
Yeah. So, okay, if you've got a place that you haven't burned and all these mesophytes have invaded, that moister leaf litter, which we have data we published showing it is indeed moist, more moist. We think that's probably why there's more ticks, but in that moister leaf litter, there are more ticks. Regardless of why there's more, there are more there, which is pretty definitive based on our data. We've, well replicated manipulative experiment. There's more in the wet leaf litter than the association of species, even though it's the same amount of leaf litter at the same sites and the same amount of time, all that stuff, standardized everything else, more ticks in the mesophytic litter.
Exactly. So like this may not be the only thing that was going on, but according to our data, it's one of the likely mechanisms that could be driving this.
To me, and to be clear, that data is pretty strong.
Yeah.
Like we know that one's more than the other, but to me, that when you put all these things together, it kind of tells a story, that is we're having to infer from some of these relationships, but we kind of have this situation where based on our timing data, the March fire didn't have, it actually potentially even had a positive effect on tick abundance the first year, but over the longer term, because it removed all that leaf litter, we still end up with a little more drier, less conducive system. So over a longer term, we see a negative effect on ticks, although it wasn't nearly as much as the June fire, which probably had a big direct effect on the tick population by actually killing ticks with the fire directly. And then you also have that long-term change in the leaf litter conditions and the species associated with it, vegetation, were probably far more negative. So you kind of, explaining why we would see such a big effect. And then over a really long term, like just, while the forest is transitioning over a long time, we probably are seeing a lot more ticks now, because when we interrupted fire, not only did we not directly kill ticks anymore, but we also have increasingly becoming more suitable and microenvironment for ticks to flourish in.
Yeah, we have created like these environments that are so conducive for,
and we can get rid of all the deer. And as long as there's a diversity of other hosts, it's probably not going to matter.
Yeah, no.
Which isn't even practical anyway, really. I mean, in what case is it practical?
It's not practical, but it's also like not ethical, because like deer are.
There's all kinds of issues. But the other problem with that is, let's say that you're in a place where you have all these tick problems, and it's, in a city.
Yeah, and you can't burn.
We're not going to be able to burn either.
Yeah.
So we're not necessarily solving the problem.
That's true.
Of controlling ticks and the associated illnesses with it. But our data is pretty telling that deer control isn't necessarily a good answer. And fire might be a really good answer when it's applicable, particularly growing season fire. But even then, that's still a problem if you're, in a park in the middle of the city.
Yeah.
It may not be an answer there. So, it's a really interesting problem.
Yeah, I honestly think we're going to have to be really creative to solve that problem in areas where it's like very unpractical to burn.
Well, we have pesticides called acaricides.
Yeah,
that are specific for ticks, but it's probably not a good idea to be spraying
just spray them everywhere. Yeah.
They have their own associated health risk. It turns out we looked into that too, trying to figure out, is that a reasonable option? And there's problems that arise in the ecosystem and with human health even that come from that problem. So definitely, folks, when you're outside,
be
check
careful.
For ticks.
Yeah.
The problem, the alpha gal, that's essentially on attachment. You could get that, so that's scarier. And then, like you said, the different pathogens are a different amount of time. But best thing is take care to protect yourself from ticks. And if you're in a situation where that's a problem and you're trying to deal with that problem, then growing season fire is an option. Based on our data, seems like the most effective strategy.
Yeah. Yeah. And I mean, we also have to point out, though, that in one of our sites, we could not burn because it was too wet.
The mesophication process is particularly effective at stopping fire during the time when we would want to apply it. To solve this problem. So it's actually obstructing us from the most effective things. So that you may end up in a situation where you need to do some other forest stand improvement practices or some sort of timber harvest to facilitate the conditions that allow you to burn at that time.
Yeah. And we still saw that on the longer term, like after a while,
fire is your friend.
Yeah, exactly. So the spring fire was also reducing even less ticks. So I would say bring fire on the ground and, on the long term is going to benefit you anyways.
Yeah.
Mm-hmm.
Yeah. But I would way more prefer
having one sick tick than 5.
Yeah. One is better than 5.
Yeah.
So, well, that was really good. Really interesting stuff. I know we have rambled on for longer than usual on here, but
thank you.
I think this is an important problem that we all need to be thinking about, and we're trying to do our part. I mean, I'm certainly not an expert on ticks, but as an ecologist who likes to eat red meat, it is a pretty important thing for me to think about.
Yeah,
so, and I know you're in that same boat. We're trying to address issues like this that are of broad relevance to people. So really cool experiment. Can't wait to see it out there and published. And glad you were willing to come on here and talk about it. And even more excited to see you join me as a colleague here.
Thank you. Yeah.
And talk about eating some good food, man.
Yeah, I can't wait to launch that. So thank you.
Yeah,
that's really exciting. Mm-hmm. Well, and thank you for having me here.
Yeah, no, I was happy to have it. Folks, again, follow us on social media. I'm at Dr. Disturbance. You'll see here recently we had a joint video with MSU Deer Lab. I think they shared it on their social media. I was with Bronson talking about forest management. We talked about ticks a little bit because I got some on me during the video.
Oh, wow. Okay.
Yeah. In a place that we had not burned like we were supposed to. So you guys can go look at that. We've got another few videos talking about these different aspects, like the leaf litter and how it looks different, how it burns differently, all this kind of stuff. So a lot of great resources for y'all to look into if you're interested. But we really appreciate you listening in. Hopefully it was interesting talk and can help you decide how and when to use fire. And again, Carol, thank you so much for coming on the show.
Thank you, Marcus. Okay.
Yeah. Where can people find you if they're looking for you?
So now I have a Twitter account that it's at Oaks and Goats.
Oaks and Goats.
Yes. Well, it's easy to remember.
Yeah.
And I will soon, by next year, have a lab Twitter and Instagram account, and I'm gonna be sure that my social media presence it's more active.
I know that you're going to do great work that's relevant to our audience because you do a lot of great fire stuff and game species stuff, and looking forward to seeing that. And you'll be affiliated, at least in part, with UF Deer Lab, so folks can find any of your stuff through us if they're looking for you and not able to find you directly.
Okay, thank you. Yeah.
All right, folks. Thanks for listening in. We'll talk to you next time.
Fire University is part of the Natural Resource University podcast network, funded by the Renewable Resources Extension Act. If you like what you heard today in this episode, please follow us on all the social media platforms at UF Deer Lab.